This is going to be objective 15. We're going to take a look at the length of a circular arc today, and then we're going to find the area of the circular sector. So let me explain to you what that means, because like if we're looking at the unit circle, I don't know if that's too much to look at or not. I told you, like, give me an angle. 30. Okay. So we know the angle is 30. That's the same as pi over 6. Very good. So what actually is pi over 6? Explain to me that. Like, what is that measuring? That's not measuring the angle. Okay, 30 degrees is measuring, like, the angle itself. But what's pi over 6? It's the circumference, right? And so when we're talking about a portion of the circumference, I'm talking about the length of the arc. Everybody agree? So today we're going to be doing that again. And so I'm not sure if you'd put 2 and 2 together and say, Miss Coins, I thought we already knew that. It's just the radian. Well, that's when your radius, this right here, what we did before, is based off if your radius is what? What would the radius of this circle be? 1, because we're talking about the unit circle. What if you have, not all circles have a radius of 1. Does that make sense? What if you have a different radius? So that's what we're going to look at today. What would the length of the circular arc, that little piece, be if it had a different radius other than 1? Does that make sense? So if it has a radius of 1 and we're talking about the unit circle, then it's just the radian. That's what that is. Does that make sense? You just take the degrees and change it into radians. So we would multiply by, if we had the degrees, you'd multiply by pi over 180, right? And that would be your radians, okay? And that would be the length of the circular arc. But we're going to look at a formula today. This is for other circles that have a different radius. Any questions about that? And then when I talk about the area of the circular sector, so what's area measured? Like, what would I shade in if I was going to find the area of that? What does area measure? The inside. So when it says the area of a circular sector, it means like that piece of the pie. Does that make sense? Whatever you're talking about. Like if it's I don't know, 75 degrees, it would be that piece of the pie. What would the area of that be? Any questions? Okay, so here are your formulas. So today, it's all about just plugging into formulas. So it should be fairly easy. I actually only have 3 examples today. Okay. In a circle with radius r, so you need to know what each variable stands for, the length s of an arc that subtends a central angle of theta radians. So that's very, very, very important. What's theta going to be? In degrees or radians? Theta is going to be whatever the angle is in radians. So what if I give you a problem and I give it to you in degrees? You can only plug what into the formula? Radians. Do you understand that? So just know that. Theta is going to be in radians. Okay. S is going to be the length of the arc. And R is going to be your radius. And again, this makes sense to us because, for example, like if your radius is 1, if we're talking about the unit circle, the length of the arc would just be whatever the radians is, right? And that's what we said. Like the length of the arc is pi over 6. Then it's just pi over 6 times 1. In this case, you know, we're going to look at things, we're going to look at stuff that has examples. Well, come on, give me an eraser. They have other numbers except for 1 for radius. Okay. Pause while you finish. All right, let's go ahead and look at example 1. So I want to find the length of an arc of a circle that has a radius of 10. So again, you know, so far in this class, we've been looking at radius of 1, the unit circle. Today, what are we going to do when you have a radius of 10? That subtends the angle of 30 degrees. So if we were going to measure this, and you had 30 degrees, okay, and this has a radius of 10. First of all, to find the length of the arc, step 1, write your formula down. What's our formula? S equals theta r. Okay? What is what called? This is theta, theta, theta. It's a Greek letter. It's just like a variable. Okay, theta. All right. So S is your length, and that's what we're searching for. Theta is your angle. So my question is, am I going to plug in, my angle is 30 degrees, but am I going to plug in 30 degrees? No, because you have to plug it in terms of radians. So what would I plug in? I'm going to plug in pi over 6. Now, isn't it nice that we know that 30 degrees is pi over 6 because we have our unit circle memorized? But what if I give you like a different degree? Like what if I give you 110 degrees? Right, you multiply by pi over 180. Does that make sense? Like you just change it like we did yesterday. Okay, just change it to radians. Any questions about that? Okay, and then we're just going to multiply by our radius, and in this case our radius is 10. So what's pi over 6 times 10? Reduce it. 5 pi over 3. So I'm telling you right now, just so you know what we're measuring, this circular arc right there is going to be 5 pi over 3. That's the length of it. Any questions about that? Easy? Okay. So, example 2. A central angle theta in a circle of a radius of 4 is subtended by the arc length of 6 meters. Okay? Find the measure of theta in radians. So, I'm going to draw it out so you understand what we're talking about. Okay? We know the radius is what? 4. And we know that the arc length is what? 6. And they're asking us to solve for which variable? Solve for theta. Okay? So theta equals, actually, I'm just going to use the first one. You can use the other one if you'd rather. But just so that I don't, some people get confused by switching formulas. I'd rather, to me, I give you both formulas, but I'd rather just use S equals theta R every single time so I know it, and then just solve it. It's up to you which one you want to use. But, so I know my S is what? 6. That's your length. I'm going to solve for theta, and I know my radius is 4. So how would I solve for theta? I'm going to divide by 4, which is going to give me what? 3 over 2, okay? Or 1.5. Now, do not be confused, because we talked about this. This is pi anyway. Pi. But I told you, and I'm going to just repeat this, it doesn't always have to be in terms of pi. Like, where would 3 over 2 be? Like if this is 0, we know this is what? Pi. But what's pi worth? 3.14. Do you understand what I'm saying? And remember, what was this worth? We know it's pi over 2 in terms of pi. But what if it's not? Like this is not in terms of pi. This is not 3 pi over 2. So please don't think that that's 3 pi over 2. Okay, that's not 3 pi. 3 pi over 2 would be way down here. Do you understand? 3 pi over 2 would be at the bottom. That's not 3 pi over 2. So what's this right here? Well, somebody tell me. You can use your calculator if you need to. Ah, point 1.57. And we know 3 over 2 is equal to 1.5, right? That's the same thing. So where would this angle actually be? Quadrant 1, like really, really close, like 1.50 is going to be right up there. Does that make sense? I just want you to understand. And you can just say 3 over 2. It's 3 over 2 radians is your answer. But I just don't want you to get confused because you're so used to like radians having a pi in it somewhere. Does that make sense? So it is possible for you to have radians. Radians is talking about the length of the sector. Does that make sense? It's your circumference around. It does not have to be in terms of pi. It can be actual numbers. Okay? All right. So let's go to area of a circle. Any questions about using the formula and finding the length? Everybody understand that theta has to be in radians if you're going to plug it in. So let me just remind you, if I want to find a sector, the area of a sector of a circle, I'm not looking, area of the whole circle would be everything that's in between it, right? Inside of it. If I'm looking for a sector though, it's like the area of that piece of pie. Okay, and to find that, you're going to use the formula 1/2 r squared times theta. And of course, what do you have to remember? Theta has to be in terms of radians. Okay, and that'll give you the area of that sector. Any questions so far? All right, so let's go to example 3. And I'm going to give you a minute to think about it. I want to see if you can actually do it, because it's just a matter of plugging into a formula. So I want to find the area of a circle with a central angle of 60 degrees. And actually, this would be the sector, area not of the whole circle, but of the sector. Central angle of 60 degrees if the radius is 3 meters. Okay, so I'm going to hit pause, and I want to see if you can figure it out. All right, so what did you end up with? Just take a guess. I heard 3 pi over 2. How many got 3 pi over 2? Good, yay. Okay, step 1. Write your formula. 1/2 r squared times theta. Plug in what we know. What do we know? We know r is 3, and we know theta is 60 degrees, but you can't plug in 60. That's number 1 mistake. You cannot plug in 60. You've got to take 60 and change it into radians. We know 60 degrees is pi over 3. Any questions on that? Then I'm just going to multiply it across. So really, this becomes 1/2 times 9 times pi over 3. And this is going to be 9 over 1. If you wanted to, you could just multiply all this across. Okay, like what's 1 times 9 times pi? 9 pi. What's 2 times 1 times 3? 6. And then what could you do with 9 over 6? Just reduce it, 3 pi over 2. And that is your area. Okay, any questions? Okay, so we're going to be good and boring today, and we're just going to try. I want you to write these down. We may not be able, like, write them all down, and in a minute we're going to take it in sections. So I think what I'll have you do is do like 7, 8, 15, 16. We'll stop, go over those answers, make sure you got them right. Then we'll tackle some of these others. Okay, and it looks like a lot, but it's not. 1, 2, 3, 4, 5. Then there's a couple there and a couple there. Okay.